In this lesson, I'm going to learn how to balance redox reactions using the oxidation number method. So the first thing we have to do is we have to assign oxidation numbers to each element within this equation. So let's start over here with the reactant side. Let's start with the zinc. And anytime you have a free element, that's going to have an oxidation number of 0. So zinc here is going to have an oxidation number of 0. Then we go to the nitric acid, and we need to assign an oxidation number for each element within this substance. And based on what charges these elements usually have, we can get started. So hydrogen here is in group 1A. So we know hydrogen here is going to be a +1. We know oxygen usually exhibits a -2, unless it's in a peroxide, then it would be a -1. But most of the time it exhibits a -2 charge. Now what we've got to do is we've got to make sure that all the charges balance out to be 0. We have to consider how many atoms we have. Here we have 3 oxygens. So you multiply here, we're trying to balance out -6, and all of this, because this is neutral, has to add up to be 0. Well, if you take a look, hydrogen will contribute a +1 towards balancing out that -6, but nitrogen here in the middle would have to be a +5. So we've just figured out that the oxidation number of nitrogen in the middle here is +5. So if we erase the math that we have up above, what you actually see in front of you are what we call the oxidation numbers for each element within this compound. Now what I want you to notice is that once you have assigned oxidation numbers for a polyatomic ion, in this case this is nitrate, the oxidation numbers do not change. So once again you come over here and you see nitrate on the product side, and you're going to see that the oxidation number here is once again +5 and -2. And that's not going to change. Anytime you see nitrate, it's going to be +5, -2. In a compound, when it's not by itself, over here when zinc was by itself, it was 0. But this zinc here is going to be a +2 charge. That is the only charge that zinc can exhibit. So we've got the oxidation numbers here, and you say, well, I don't see how that adds up to be 0. Well, let's do the quick math. 2 times 3 is 6 oxygens. Times a -2 would be a -12 that we're trying to balance out. We've got 2 nitrogens, each at a +5, so that's going to be a +10. And we have the +2 for the zinc, so sure enough it all does add up to be 0. So if we get rid of this math and we just look at the oxidation numbers, we're going to actually see that it's +2, +5, and -2. And we need to continue with this trend. We need to go ahead and assign oxidation numbers for the other 2 products. So if we go over here, once again oxygen's a -2. So we're trying to balance out a -4, and this is neutral, so it's all got to add up to be 0. So this is going to be a +4. So the oxidation number here for the nitrogen is a +4. So we're assigning oxidation numbers to each element within a compound. And then for water, it's always a +1, -2. Now if you're going to balance equations using the redox method, we have to try and identify what is being oxidized and what's being reduced. So let's identify oxidation first. We notice that zinc is going from no charge to zinc having a +2 charge. We say here that zinc has been oxidized. So we can show that zinc with no charge is going to zinc 2+, it's going to the cation. And in this process we can say that we are actually losing 2 electrons. In the loss of 2 electrons, we have a special name for this. This is called oxidation. And whatever is being oxidized, we need to make sure that we actually call this a reducing agent. So zinc here is actually a reducing agent. So we're going to go ahead and label this as a reducing agent. So whatever goes oxidation is causing something else to gain what it is losing. So zinc here is our reducing agent. It's causing another element to gain those 2 electrons that it's going to be losing. So zinc here is considered our reducing agent. So now if you have one thing being oxidized, if you have one thing losing electrons, in this case 2, simultaneously we've got to have something that is gaining those electrons. So we need to look for an oxidation number that is going down. So in this case we're going to notice that the decrease in oxidation number is going to be from this nitrogen to this nitrogen. Now there is a nitrogen that's not decreasing. We don't want to identify that one. We need to identify the reduction. So we've got our nitrogen with a +5, and it's going down to nitrogen in a +4, and obviously that is going down by 1. And we say here that this substance has been reduced. Or if you will, we can say that this substance is going to be gaining electrons, because you can't have one without the other. If you have one thing losing simultaneously, you have to have something else gaining. So whatever is being reduced, we can call this entire substance, not just the nitrogen, the entire substance here is called an oxidizing agent. An oxidizing agent causes something else to be oxidized. It causes something else to lose what itself is trying to gain. So nitric acid here is serving as the oxidizing agent because the nitrogen within it is decreasing its oxidation number by 1. So as you can see here, we have a gain and loss of electrons that do not balance out. What we have is one substance losing 2 and the other one gaining 1. So what we want to do is we want to balance this electron transfer. So to balance that, I'm going to put numbers over here to the left. And we can see that 1 times 2 says that for every 2 electrons that we lose, 2 times 1 says that we're going to gain 2. Now what I want to do is I want to use these numbers out here as coefficients up in my balance equation. So zinc with no charge right here, it says we need a coefficient of 1. There's our 1. Zinc with a +2 charge is located right here. It says we need a coefficient of 1. So I'm going to put a 1 there as well. Nitrogen with a +5 on the left-hand side of the arrow. Notice there are 2 nitrogens, one on the left and one on the right. But it's a nitrogen with a +5. It says we need a coefficient of 2. So I'm going to put a 2 there. And this nitrogen with a +4, I'm going to put a 2 here. And this should help us start to balance this equation. Now it may not be completely balanced, but we can do the rest by inspection. So if we take a look at what we have, we notice that the zincs are balanced because those participated in the redox. And the nitrogens that participated are balanced as well. We've got 2 nitrogens here, and then we've got 2 nitrogens here. So the nitrogens that participated in the redox, they are balanced. However, notice that there are 2 more nitrogens here that did not participate in the redox. And we've got to consider those as well. You obviously just can't ignore them. So how many nitrogens do we have total? Well, we have 2 that did participate in the redox. We have 2 that did not, but that is a total of 4. So I'm going to change this number right here from a 2. I'm going to change that to a 4. And in the process of giving me 4 nitrogens, because remember 2 nitrogens participated in the redox, 2 did not, that now gives me 4 hydrogens. I'm going to go over here and I'm going to put a 2 for this to give me the 4 hydrogens. And now if we step back and take a look at it, we notice that we have 12 oxygens, and 2 times 3 is 6, and 4 more is 10, and 2 is 12. So this equation is now balanced, so we're able to balance this with the redox method. So our balance equation is 1 zinc plus 4 nitric acids is going to produce the zinc nitrate, one of those, 2 of the NO2s, and 2 waters. So what we just accomplished is we balanced this redox reaction by simply looking at oxidation numbers, essentially balancing the gain with the loss of electrons.